Welcome to IOQM 2025. In this series of videos, we will solve the problems of Math Olympiad 2025. This is for the region 4 and 5. Okay, there are two sets of papers this time. Okay, two different papers are there. So in this series of videos, we will solve the region 4 and 5. In this video, especially in this video, we'll solve the 2 marks questions which are from questions 1 to 10. Okay, we will get another 3 more videos to complete this paper, 30 questions. So paper pattern is exactly same, 30 questions, 3 hours, 100 marks, and then question 1 to 10 are 2 marks, 11 to 20 are 3 marks, and 21 to 30 are 5 marks. Okay, in this video, we will solve the 2 marks questions. Okay, let's do. Let ABCD be the quadrilateral in the xy plane with AB parallel to CD and AD equal to BC. Suppose A is 0, 0, B is 10, 0, C is 8, 5, and D is A, B. Determine the value of A square B. Yeah, this is a simple solution. If you look at the coordinates of the ABC, the only way you can construct this is this way. This is nothing but isosceles trapezoid. Okay, so AD equal to BC, and these are the values. So if you drop from D, A, B to AB, that is F, you will get. So this coordinate, x coordinate will be A, and y coordinate will be 0, because if you see the A and B coordinate, y coordinates are zeros. Similarly, if you drop from C also, you'll get 8, 0. Okay. So this is the isosceles trapezium quadrilateral, and AB is parallel to CD, which means B is equal to 5. Okay. Uh, yeah, if you see D, this should be 5 only. There is no other option because height is same, right? Height is 5, 5. It should be 5. Then we need to find the A. How can you get A is very simple. This E is 8, 0, we know. So distance EB is 2 units. So obviously A false will be 2 units. So A is 2. Okay. So if A is 2, B is 5, then A square B is nothing but 20. That's the answer. Okay. I think this is a very easy question. Okay, you just draw the diagram correct, and it cannot be a parallelogram because look at the coordinates. You cannot draw this line like this. Okay, BC like this. Then also opposite, these two will be equal length, but 10, 0 this is okay, and this is 8, 5. So this is the only way you get the quadrilateral. Okay, isosceles trapezium. Next. A function is defined on the set of positive integers such that if n is odd integer, then f of n is n minus 1. If n is even integer, then f of n is n square minus 1. Determine all sum of all possible values of n such that f of n equal to 99. Okay. So let's take case by case. First, let's take n is even. So f of n is equal to f of n inside is basically n is even, right? So this value is nothing but I have to take even, which is n square minus 1. Okay, so f of n square minus 1, n square minus 1 is odd because n is even, n square is even minus 1 is odd. So f of n square minus 1 is nothing but n square minus 1, which is equal to 99. If I solve it, I get n square equal to 101, but I don't get any possible integral solution for n here. Okay, because n is integer, right? Positive integer, the two. So there is no possibility. Now let's take n as r. So f of n is equal to f of n minus 1 because f of n is odd, f of n is n minus 1, and f of n minus 1 is nothing but this is even. N minus 1 is even because n is odd, n minus 1 is even. So f of n minus 1 is n minus 1 whole square minus 1, which is equal to 99. If I solve this one, I get a quadratic equation n square minus 2n minus 99 equal to 0, which is nothing but n minus 11 into n plus 9, which is equal to 0, or n is equal to 11 comma minus 9. So n should be only positive integer, so only one value possible, which is n equal to 11. That's the only solution. So sum of possible n is also same, which is 11. Okay. So this is also easy, definitely. Next. Find the number of positive integers n less than or equal to 100 such that n is not divisible by any prime number other than 2 or 3. Okay. So n should be divisible only by 2, either 2 or 3. That's it. Okay. So let's see. The number should be represented in the form of n equal to 2 to the power of p and 3 to the power of q, which should be less than or equal to 100, right? Only then you get divisible by 2 or 3. Okay. So no other prime should be dividing this number. Okay. So now the question is simple. We have to just do the counting problem. So let's see the table p, q, then what are the values possible, and then what are the total number of possible values. Okay. So let's take p as 0. Okay, we will run on p actually. P as 0. then q is 1 to 4, because if I take q also 0, then it will become 2 to the power of 0 and 2 to the power of 0, which is 1, and 1 is not divisible by 2 or 3, right? So I'm taking 1 to 4, and I kept 1 in red color. We'll come back to that. Okay. Uh, so if q is 1 to 4, the possible values are 3, 3 square, 3 cube, and 3 to the power of 4, which are 4 possible values are there. Okay. Now p equal to 1, I get q as 0 to 3. So my possible values are 2, 2 into 3, okay, 2 into 3 square, and 2 into 3 cube, which is 4. So similarly, I will go through all, and at 6, p equal to 6, q will be 0, so I'll get only 2 to the power of 6, which is 1. Okay, now let's understand the condition very clearly. Okay, n is not divisible by any prime number other than 2 or 3. It means that it should not be divisible. It should be divisible only by 2 or 3, but even those two also need not be, are not mandatory. Okay, it should not be divisible by any other prime other than 2 or 3. Okay, and it did not give information that it should not be divisible by 2 and 3 also. Okay, so p equal to 0 and q equal to 0 condition also valid actually. Okay, the 1 value 1, which is not divisible by 2, not divisible by 3, but it meets the condition that it is not divisible by any other prime, right? That condition it uh, handles, right? So which means we should consider that value also. So that is 1. So 1 value. So sum of all this total is around 20. So the 20 is the answer. Okay. I'm sure most of the kids would be missing this part 0 0 actually. P equal to 0, Q equal to 0. So I would say moderate. Problem is simple, but I think very few will get correct answer, I feel. Okay. So let's see what's the next. The 6 faces of cubical die are numbered with 2 to the power of 0, 2 to the power of 1, up to 2 to the power of 5 in such a way that the product of numbers on any pair of opposite faces is 2 to the power of 5. Two such dice are stacked up on top of another, one on top of another. If n is the greatest possible sum of 9 visible numbers, and find the sum of the squares of the digits of n. Okay, so let's see. So if we have to have the dice with these numbers, okay, and opposite sides product of opposite sides should be equal to 2 to the power of 5, then possibilities are 2 to the power of 0 and 2 to the power of 5 should be opposite sides, and the sum of these two is 33. 2 to the power of 1 and 2 to the power of 4 should be opposite sides. Sum of these two is 17. 2 to the power of 2 and 2 to the power of 3 should be opposite sides, and sum is 12. Okay. Now let's understand the uh, top. Okay, top die. Okay, top die will have 5 faces open and one is hidden. Okay, hidden on the top of bottom die. Correct. So the 5 faces I should take the maximum values and hide the least one. The least one is 2 to the power of 0. So I will hide the 2 to the power of 0. So the total on the top die is nothing but 2 to the power of 1 plus 2 to the power of 2 plus 2 to the power of 3 plus 2 to the power of 4 plus 2 to the power of 5, which is nothing but 62. So this is on my top die. Now bottom die has two sides, two faces closed. So I should consider whichever is the minimum value that those two should be hidden. So that is 2 to the power of 3 and 2 to the power of 2. These should be hidden faces. Other 4 should be open. Correct. So if I hide these one, I get sum on the bottom die is 2 to the power of 0 plus 2 to the power of 1 plus 2 to the power of 4 plus 2 to the power of 5, which is 51. So total is 51 plus 62, which is 113. Now the question asked is the sum of squares of digits of n, which is nothing but n equal to 1 square plus 1 square plus 3 square, which is 11. N is, so sum of squares of digits is 11. That's the answer. Yeah, this is easy, definitely. Next. Let n be the quotient of x to the power of 2025 in the expansion of x plus 1 into x square plus 3 into x power 4 plus 5 into x to the power of 8 plus 7 up to x to the power of 1024 plus 21. Okay. What is the remainder when n is divided by 100? Okay. What is the remainder when n is divided by 100? And n is what is n? N is quotient of x to the power of 2025. Okay. So if you see here, the x to the power values are binary numbers. Okay. This is 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, up to 2 to the power of 10. Correct. So which means there is a pattern actually. Okay, what is the maximum x to the power of x power will get if I multiply all this? The maximum I get is uh, 2 to the power of 0 into 2 to the power of plus 2 to the power of 1, that is x into x square into x power 4, right? Everything. So I get the powers will be added up, that is 2 to the power of 0 to 2 to the power of 10, which is equal to 2 to the power of 11 minus 1, that is 2047. Okay, now I am looking at 2025. So I should subtract 22 x to the 2 to the power of basically x to the power of 22 out of it. How can I get x to the power of 22? As I said, these are the binary logic. Okay, this is binary numbers. 2 to the power of 12 can we can get from only one way, that is 10110. Okay, right? That is 2 to the power of 16. If this is 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4. There is a binary number 22, right? So 16 plus 4 plus 2 equal to 22. There is no other way 22 is possible in a binary logic. Okay, it's a unique number, right? You cannot represent 32 in decimal number in some other way, right? Only way is 32. Similarly, 22 can be represented only one way in binary logic, that is this number. Okay, so I should remove 2 to the power of what are the numbers I should remove? X to the power of 2 to the power of 4, x to the power of 2 square, x to the power of uh, x to the power of 2 to the power of 1. These are the uh, values I should remove. So, which means in this space, I will get the plus k part of it. 2 to the power of x to the power of 2 to the power of 4 constant term is 9. Okay, because it's going 1, 3, 5, 7. So, next one is 9. And x to the power of 2 square is 5. X to the power of 2 to the power of 1 is 3. So 9 into 5 into 3 is the product which will be added, to this quotient. Okay. So quotient of x to the power of 2 to the power of 25, sorry, not 24. Okay, this is 25. 25 is 135. Okay, 9 into 5 into 3, that is 135. So they are looking at n mode 100, so that is 35. Okay, that's the answer. Next. Yeah, this is medium, but you can actually you don't need to understand this binary logic and all. You can see what is the possible combination, and you don't get any other combination actually. Okay, so this is to confirm that there is only one combination. Okay, next. The sum of four distinct prime numbers is 240. If none of the four primes is greater than 70, what is the smallest of the four numbers? Okay, so this is simple. He said sum of four distinct primes is 240. So let's take, even if you take average 240, the average is around 60. Okay, 60 is a big number, and we are looking for primes from 1 to 70 only, right? So let's start counting from the biggest to smallest. Okay, from 70 you come back and check which are the primes, you consider them. Okay, so 67, 61, 59 and 53, these are the top four primes starting from 70 down to 1. Okay, now sum of these four is equal to 240. So these are the four values, and what is the smallest of the four numbers? Okay, that is the question actually. That is 53. That's the answer. Okay, smallest of the four is 53. Not we are not looking at sum. Okay, 53 is the answer for this one. Okay, this is definitely easy one. Next, consider a 2 by 3 rectangle made of 6 unit squares. In how many ways you can fill the 6 cells using the numbers 1 to 6, one in each cell, such that any two adjacent cells are co-prime to each other. Okay, so let's understand this one. First, 6 is co-prime with 2, 3 and 4. Correct? So if 6 is in middle, then none of the you cannot keep any of these 3 actually. So 6 in the middle, definitely not possible option. Okay. So if you consider this one, okay, 6 in these two is not possible. 6 has to be in the corners only. Because if 6 is here, you have to keep other numbers here. So one of them you will get a co-prime. Okay. So 6 is in the corners. So which means number of options for 6 is 4. Possible cells for 6 are 4. Okay. Any of these corners. So let's take 6 kept in one of the corner. Okay. If you keep 6 in one of the corner, then 2 comma 4 cannot come here. Okay. 2 comma 4 or 3. Okay. They should be in this one only. So if you keep 2 comma 4 here, then 2 comma 4 cannot come one of these two also. So 2 comma 4 has only option is these two cells. Okay. So possible cells for 2 comma 4 are 3, and 3 is only, this is the only possible cell for 3. If 6 is in the one opposite corner. Okay. So possible cells for 3 is 1. Possible cells for 1 comma 5 is the remaining two, which is these two. Okay, so if you put this properly, you will understand very easy problem. So total possibilities are 4 into 2 into 2 into 1 is there, of course. Okay, which is 16. That's the answer. This is definitely easy. Okay, next. How many positive integers n less than 100 are divisible by all positive integers I such that I cube is less than or equal to n? Okay, so this is really very surprising question in 2 marks actually. This is really hard actually. Okay, so let's understand how to do this. It's a counting problem finally. Okay, let us understand by example. Let n equal to 30. Okay, which means divisors should be all possible I values for which I cube is less than or equal to 30. Okay, so if I is less than or equal to 3, then I equal to 1, 2, 3. Basically, this is the uh, possible divisors. Okay, so since 30 is divisible by 1, 2, 3, so n is in the solution set. Okay, so hope you understand this one. This part is if I is less than or equal to 3, which means I is 1, 2, 3, all 3 should divide this 30, which is dividing. Okay, now I cube should be less than or equal to 30, correct? So this is what we need to understand. So let's make a table to understand how many will be possible solutions. Okay, we make a table with I cube, then condition, first condition is n should be between I2, I cube, I plus 1 cube, I2, I plus 1 cube. Condition 2 is n should be divisible by uh, whatever is the I actually, right? Then possible values of n and then total, right? So let's understand this one. Let's take I equal to 1. So I cube also 1. Okay. So n can be from 1 to 7 because it cannot be 2 cube because I is only 1, right? So I can go up to 2 cube. That means, okay. Now condition is divisible by only by 1. It should be divisible only by 1 because I is 1. Okay. I is not 2. Because so 1, 2, 3, 4, 5, 6, 7, all these are possible n's, okay, which are divisible by 1. Okay. Why we are not taking 8? If I take 8, okay, if I take 8 as n, then 2 cube also part of it, right? Then if 2 cube is part of it, 1 to n, correct? 1 to n, 2 cube should be divisible by 1 comma 2, right? So that will come in the next step. So let's understand that part later. So in this first condition, when I equal to 1, only possible n's are 1 to 7. Okay, so these are the 7 total. Now let's take I equal to 2. So I cube is 8. Now we will understand it very well here. Okay, I cube is 8. Okay, which means the n should be from 8 to 3 cube. N should be from 8 to 3 cube, that is 27, right? And the condition is it should be divisible by 1 and 2, that's all. Okay, not by 3 because it is not 3 cube, right? It is n is not greater than 3 cube, n is less than 3 cube. So it should be divisible, all these numbers should be divisible by 1 and 2. What are the possibilities 1 and 2? Obviously they are the even numbers from 8 to 27. Okay, that is 8, 10, 12, 14, 16, 18, 20, 22, 24 and 26. Okay, these are the 10 numbers possible here. Now if you take I equal to 3, I cube is 27. So 27 to 4 cube. 4 cube is nothing but 16 into 4, which is 64. Correct? So from 27 to 64, we need to look for numbers which are divisible by 1, 2, 3. Okay, that is 6. Correct? 1 into 2 into 3. 6. That means I should take numbers which are divisible by 6 starting from 27 up to 64. That is 30, 36, 42, 48, 54 and 60. These are the 6 numbers possible. If I take 4, 4 cube is 64. Okay. So I should look for numbers which are between 64 and 125. That is up to 100 basically. Okay. Because maximum is 100. Okay. And should be divisible by 1 into 2 into 3 to 4. That is 24. So I am looking for 24 multiples starting from 64. That is 72, 84 and 96. These are the 3 possibilities. Now 5 is not possible because 5 cube is already more than 100. So I will not get any numbers here. So these are the total numbers which are 26. This is the answer. This is definitely hard for a 2 marks question here. Okay. And understanding is very important. Problem looks actually easy once you understand the uh, logic of what is this I cube and I actually, right? But otherwise, it's definitely harder. Okay, next. Find the largest integer n such that a square of side length n is contained in a circular disk of area 1000. Okay, so for this one, definitely should draw the picture first to understand. There is a disk, there is a square, correct? So draw a disk, there is a square. Square side is n. Okay. Now the question is, what is the maximum size of n such that pi r square is uh, less than or equal to 1000? That's the question, basically. Now, what is the relation between r and n? Okay, this is r. Okay, this is n by 2. This is n by 2. So I form a right angle triangle here. So I can get the r in terms of n by 2. Correct? So that's my relation. So r square equal to n by 2 square plus n by 2 square, which is uh, 2n square by 4, that is n square by 2. Okay, so my pi r square, which is less than 1000, is nothing but pi n square by 2, which is less than 1000. Pi n square by 2. Okay, so if I solve this, n is less than or equal to square root of 2000 by pi, which is approximately square root of 636. So my integer value, right? I am looking for integer n. So my n is the maximum n is, right, 25. 25 square is 625, that's the closest to 636. So maximum n value is 25, that is the answer. Okay, next. This is definitely easy. Once you draw the picture, I think you can get it. Find the largest positive integer n for which inequality sigma k equal to 1 to 2n minus 1 to the power of k square is less than 100 wholes. Okay, so first thing is expand the sigma, then you understand what is this problem is. Okay. Sigma 1 to 2n minus 1 to the power of k square is nothing but minus 1 plus 2 square minus 3 square plus 4 square minus 5 to 5 square. Okay, it goes like this up to, what are the last terms? Minus 2n minus 1 whole square plus 2n whole square. Okay, now I can rewrite this very easy way. Okay, this is nothing but sigma k equal to 1 to n, and I am taking two terms. Okay, that is 2k square minus 2k minus 1 whole square. Okay, right? If I take 2 here, 1, 2, 3, 4, 5, 6, all are up to 2n. 2 square minus 1 square. Okay, 4 square minus 3 square. Like that, 2n square minus 2n minus 1 whole square, right? This is the one. And this is a square minus b square form. So if I simplify it, I get uh, 4k minus 1. That's into 1 basically. So this is sigma k equal to 1 to n, 4k minus 1. If I apply sigma inside, 4 into sigma n, basically sigma n is nothing but n into n plus 1 by 2 minus sigma 1, sigma 1 1 to n, so it is minus n. So this is nothing but 2n square plus n less than 100. Okay, now this is a, I get a inequality 2n square plus n minus 100 less than 0. If I solve it, n is approximately 6.5, I get 6 to 7. So I am looking at the integer value, so 6 to 7. Now you look for sigma of 6 and sigma of n equal to 6 and n equal to 7, you try and see what happens. Okay, so 2n square plus n is approximately 78, which is less than 100, which is okay. For n equal to 7, 2n square plus n is 105, which is more than 100, so this is not valid. So maximum largest positive integer of n, possible integer n is 6, that is the answer. Okay, I think this is easy problem, just calculation is easy. You can actually solve this by just counting method also. You start checking, take some value of n and start doing, because it's 6 is not very big, you will get the answer anyway, right? So definitely this is easy. So these are the 10 2 marks questions, and in my next video I'll make 3 marks questions for the region 4 and for IOQM 2025. Okay, until that, keep doing maths. Thank you.